Yeah, so it's great to have Junliang to give us a talk about graph-based blockchain transaction network modeling. Junliang is a PhD student at McGill University, supervised by Professor Xue Liu. Yeah, without further ado, let's welcome Junliang for the talk.
Okay. Shall we wait for a bit, like 1, 2 minutes more, or just start?
That's okay. That's okay. We are recording.
Okay. Maybe 1 minute more, I will start. Oops. Okay, I possibly start. So it's a pleasure to have this chance to present the basically my personal experience and research. It's a pleasure to have to be here, and I want to thank Dr. Li Yuxi for starting this group and creating a space where researchers and industry people we can change the idea of AI and blockchain. And even though I assume that a portion of the audience may already got known what blockchain is, and I choose to begin with a set of fundamental preliminaries to have a common base for the discussions to just in case someone in the audience are not familiar with blockchain. So that's for you. And I'll try to keep the concept simple, and I will welcome any engagement during this presentation. So next page. A blockchain is basically a chain of blocks. Well, of course, it's called blockchain, and a block contains transactions. This is the core concept I want to mention today. It's just I'm interested and curious in the transactions. There be other people who are curious and who study and do research about consensus or blockchain networks or infrastructures or like cryptographic stuff. My research focus was on the transactions, has been always on the transactions. So here is a simple graph. You have blocks 1, 2, 3, 4 until n. So one is oldest and is newest. You always have the transactions happen in every block. And a transaction is basically address, transfer some tokens to another address. To be simple, it's very simple. And to be a bit more detailed, this blockchain stuff is something you have a sequential blocks, of course, and each block contains the transactions we already mentioned. And every transaction is a record of what tokens were sent from address A to address B. And blocks are linked, which means here you can see like in addition to the body of transaction data, we have the hash of previous block, we have the time step, we have nonce and Merkle root. I don't need to explain every details, but basically all the transactions and previous and all the header stuff were hashed, and the hash of the previous block are stored in the next block. That's how they linked. So um, every all the data are hashed, so you cannot change anything. Even one block, anything changed, the hash will be totally different. So all these hash are uniquely stored and chronologically linked. Therefore, it's basically from the oldest block to the newest block. Every block is linked by the previous hash of the hash of the previous block. Therefore, they're ordered by time. We call it block height. Like the higher the number, the newer the block. And blocks cannot be changed once added. So it's immutable, which means anything cannot be changed once it's on the block, once it's finalized by the networks. So it's basically all the blockchain look like this. The difference is possibly like there are some chains, they have different way of consensus. They have different way at different times of the block generation time. For example, Bitcoin is like every 10 minutes there is a new block. Ethereum is like 1, 2 minutes, and Solana is much faster. That's one difference. And also they have difference in like every blockchain has maybe different numbers of transactions. Like one block may contain 1,000 transactions, 2,000, 10,000, depends on the blockchain. So these things are how they're different. And here is a figure for all the, not all, but the most influential and most commonly seen blockchains. Do you guys know which one is which? Like I have the first one, of course, Bitcoin, right? Bitcoin. And the second one is like recently the price goes up very much is the Ethereum. And basically, I think Wall Street got interested in those RWA, like the real assets tokens and the stable coins. Those things make the Ethereum price goes up quite a bit. This Ethereum is showing as a blue circle with a split diamond emblem. So this kind of this shape, right? This kind of diamond shape is Ethereum. And we have this, right? We have this black circle with three angle gradient bars. This is a Solana, like forming an S. Solana is famous for the meme coin. Those kind of, you have a funny image of a dog, of like anything like the meme coin. Every just a picture you can get of that, like coins initialized in Solana, just for like you can use like pump.fun to just upload the image and start a coin. And the Solana is famous for its fast speed, and also you can easily launch a meme coin on that. So it's a king of meme coin that so many retails and regular users like that. It's kind of like the big institution prefer Ethereum because Ethereum is kind of the second largest blockchain in terms of market value. And the large institute likes Ethereum is because it's secure. It's basically for big institute. It's kind of expensive for regular people, for retails, but institutes like Wall Street, like traditional finance people, they prefer Ethereum. That's why recently the price has went up so much. Like Solana and the price kind of but every time when there's like when the interest went down, the a lot of retail monies just went to Solana and meme coin, and the altcoins price will go up once that, but that's not happening now. We hope it happens. And we have Binance Coin, this BNB. Like Binance is a trading platform for coins, and we all know that the now is the biggest. It has its own native coins, of course, Binance Coin. And we have all those you guys may have noticed in the figure, like stable coins are indicated by the dark outlined block boxes, including Tether, DAI, USDC, Binance USD. All those four stuff coins in the black colored box are stable coins, which means the one coin is $1. And they have a bit of difference. Like Tether was the first, and then by USDC. USDC is kind of more regular, like regulation preferred. So it's kind of more like European Union, SEC prefer USDC because they're fully, the Circle company launched this coin are fully like happy to be compatible with the regulations, happy to welcome any regulation. But Tether was not, was like a more like a black box, but it was the first one and it was the biggest market one. And so European Union kind of hate USDT, kind of, and I don't mean hate, but dislike it and prefer USDC more. And their later DAI, like launched by algorithm, like something like based on smart contract to maintain the coin price of DAI. And they're also Binance USD, like launched by the biggest platform trading platform Binance. It has its own kind of stable coins. So this just gives you some ideas of what the token likes, but they're just this is just an icon. It doesn't mean anything, but it's fun to know like which icon is which. So back to our topic. I will start with the some basic stuff of transaction address and the smart contract. So basically, we say transaction is just a transfer from address A to address B with the like what token you transferred, how many tokens you transfer. So for example, you can transfer like 2 Ethereum, 3 Ethereum from A to B. Well, this is A to A, sorry, I mean A to B. And also it carries an input, which is data. So basically, blockchain has Bitcoin has no smart contract, but Ethereum later many blockchains have a smart contract, which means their logic on the chain. So address A transfers some token to address B. one option is like one thing could happen is just purely token transfer. Like I gave you to Ethereum. That's one thing could happen. Another thing is I transfer some tokens to a smart contract. Like address B is a contract. I transfer some tokens to a contract in order to trigger something. So I need to carry an input data to say what I want. For example, address B is a swapping service. For example, if address B is a Uniswap contract, and I have one Ethereum, I want to switch this one Ethereum to like 4,000 USDC. I want to swap my Ethereum to Stablecoins. Then I will send the transaction to a contract of Uniswap and trigger a function like swap. I need to send the tokens, and in the address B, some logic happen. The smart contract automatically swap the token for you, and get you back something. So it's very common. Like the one transaction you see is actually calling some function from A to B. It's not just a purely money transfer. It's something like you call function in address B. So just keep in mind, like this is like the most the topic today, and we are always interested to see what's going on because the input data need to be decoded, and in address B we don't know all the possible of like address B, right? We address B could be any contract, and without reading the contract, without reading the ABI of the contract, we don't actually know what contract B is doing. It's like it's like coding, right? You can write any program in address B, so we don't always know what's going on here. And also there are time step and they're like block height. I don't have everything put here, but mostly we always use token value input, which is the function related stuff, and time step and hashes of the transaction. Obvious, we care about this. So let's see a detailed version. So this is a real transaction. I got one transaction from Polygon, and it looks like this. You guys see like there's block number, there's time step, there's hash, there nouns, there block hash, etc., etc. And like we mentioned, we care about this from, right? It's from this address. So on Ethereum or all the Ethereum compatible blockchains, the address will look like this. It's like 30 some bytes of like start with 0x and blah 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 something like 230 ABC some stuff. So it's a byte it's address. Address look like string like that. So from this address to this address, transaction some values. Here's zeros. Basically, there's no native token got transferred. So, but here's the input. Like I mentioned, this is the data of what's exactly happened. And if we see the thing on the right, so basically, if you put this input to decode, and there's multiple way of decoding that, but mostly you can copy the ABI of the contract and use some packages. But you can also do that manually, but we don't want to say the details of that. But um, to be simple, is after decoding, this input was something like a function called mint and swap. And there's actually the token ID, which is also string. In this case, this string means NUSD, so this is a stable coin, and the amount is like 1,300. So this transaction you see is from this address to that address, and that to address is a smart contract, and that smart contract offer a service where you can mint and swap some stable coins, and the input data contains that, and eventually the result is like to the address 0x 8003 DC. That address on the right, not on the left. On the left is a contract. On the right is actually the final destination of the address to say, okay, let's mint 1,300 USD in USD, and let's send this 1,300 USD to that address. That's how this transaction, that's what's actually doing in this transaction. So you see that we have some low-level data, and we initially we know, oh, this is from this address to that address, but without decoding, we don't know actually what this transaction is doing because they're all smart contract call function calls. And if you extract data like I always do, like there are also ERC20. I'll explain what ERC means later, but this is basically fungible tokens. Like on Ethereum, for example, on Ethereum, the native token is Ethereum. On Solana, the native token is Solana, right? But on Ethereum, you can also send tokens like Tether, tokens like USDC, because those are stable coins. They don't have a chain. Like Tether doesn't have a Tether chain. USDC doesn't have a USDC chain. Those tokens are not native tokens of any blockchain. So there will be a fungible token of ERC20 standard token on Ethereum. So which means they can be in multiple chains. They don't have its own chain. And on Ethereum, the standard is called ERC20 for these coins. Not native Ethereum. For example, this USDC. And if you attract the what's in the blockchain, it's always look like this. So you have a front address to address value. We haven't mentioned that. This is just give you an example of what a block will look like. There will be multiple rows of transactions and always look like that. You have token symbol. So for example, the first row is from this address to the address with the value three 398 something. And also it's a USDC coin, and also it has some input data. But here it should doesn't show that, but you guys know that there exists that. There could be other things. So in addition to ERC20, which is a fungible token, right? Fungible token means there are multiple same tokens. You can have one USDC, 10 USDC, 100 USDC, 1,000 USDC. They're all the same. So you have multiple of the same tokens. And there's also the NFT, which is a non-fungible tokens, is under the ERC721 standard. This means every token is just a unique one. So basically, fungible just means it's unique. And for example, here I used to collect data from the top USB, the most influential NFT programs, and one of these is this Bored Ape, this funny monkey, right? That's used to be very expensive. I think now the price is high as well, but it's just not as higher as the like back to 2021. It's extremely expensive, like this Bored Ape Yard Club, like this monkey, right? This ape. And you guys see that there's a value, but it doesn't mean value. So in the transaction of ERC 721, which means the transactions of NFTs, the value here means the index. For example, you have 10,000 monkey, right? Each monkey looks different. Each ape is a unique one. Using this Bored Ape Yard Club as an example, this value is the index. So 7116 in the data means the 7,116th of the ape. So it's kind of from number 1 to number 10,000. This one is like 7,116. That one, right? The value is not value, it's the index of the NFT in that collection. And there is a transaction value you can see. That's the one in of Ethereum. So basically, transaction value fields indicates the ETH value that was transferred alongside with the NFT. So between the sales, like the buy and sales, like one trade of the NFT, how much Ethereum spent on this NFT was the recorded in this transaction value. And we say the contract, this is an example of what the contract look like. So this contract, if you extract the functions of this contract, you will see this. So this contract 0x3 7D to 26D something. If you put that, you grab the ABI of that contract, you decode that, you can see above, there is actually a list of functions of what's the function available in that contract. So in this one, there's deposit, there's the mapper rule, map tokens, all these get chains ID, all the things you can call. You can actually send some tokens to this address to trigger these functions if you want to do that. That's just demonstration of what the smart contract will look like. You always have a list of function you can call. Okay, so currently we mentioned what's a transaction, what's a token, so what's a kind of like a ERC20, ERC721. So what is your ERC? It's basically Ethereum request for comments. In the Ethereum community, something like if a new standard will be initialized, they first have a Ethereum improvement proposal, EIP. So you always see like EIP is something, a number. That's something like anyone can do. you, me, we all can do that. If you have ideas, say in the future, the token standard should be blah, 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 and you can always have a proposal. And that's called Ethereum Improvement Proposal, EIP. And once that widely vetted and peer reviewed, they will be adopted by the consensus of the Ethereum community and eventually be implemented and added to the newest blockchain client. So, which means they're finalized. So ERC is kind of wasn't proposal, but eventually agreed by most of the people in the community and will and added to the Ethereum. For example, ERC20 was proposed back in 2015, like 10 years ago by Fabrian, this guy named Fabrian Vogelsteller, and that's formalized by the Ethereum community in 2017, so 2 years later. And similarly, the standard for NFT was authored by William Antrinker and finally finalized in 2018 following the community approval. And they will have unique list of functions. So yeah, for example, the current standard of ERC20, like all the USDC, USDD, all the stablecoin are USD20, are ERC20 basically. So in the ERC20, the standard the template, the standard way of having a smart contract must have this function like total supply, balance of transfer, approved, transfer from. So no matter which tokens you are interested, you go to their smart contract. If it's a ERC20 token, we always have this kind of function. So you don't need to look and read what's functions there. If it's a ERC20 token, the contract must have this function. So you can call the balance, you can make a transaction to see what's the total supply of this token, right? So that's the ERC20. And for ERC721, we said it's non-fungible tokens, NFT, right? It doesn't have the total supply because we know that every coin is just one coin each token. But it does have some unique function ERC20 doesn't have. That's why we need this different standard, right? That's each one has unique functions for the purpose of this or the use case of this token. For NFT, we know that every token is a unique one. And we know that it has no total supply function, but it does have the owner of function. So you can easily check who's the owner of this NFT because every NFT is just unique. And some of them are extremely expensive. And they always want to validate like who's the owner. And also you have token URL, which is basically the URI of this NFT, on the metadata, the picture. If the NFT is an image, it's for an image, it's a URL to an image. If the NFT is for a piece of music, it's the URL to a piece of music. So it's basically a address to a link to something like off chain. So we know that NFT, like ERC721, has got this functions, and we have a bit more like ERC3643, ERC 5560, and also ERC 6066, 6065. So these all those three new standard are for the RWA tokens. For recently very quite hot is the real world assets RWA. So it's kind of like U.S. Treasury gold, like rent of some house. All these things can be tokenized. Even the digital concurrency of of a country can be a tokenized, or the data market could be tokenized. And all those three standards are for the kind of new, because ERC20 is ERC20 for like stablecoin, ERC721 for NFT. Everybody knows that, but these three are not everybody know. There's a quite new, and they have their uniqueness. Then one is for like permission security token. Security means that you can basically share the interest. Uh, imagine there's a house, and the house rent is 10,000 USD per month, and let's assume like it launched like 1,000 tokens. Like each owner of the token can share the corresponding proportion of the rent, for example. They kind of want to do that. And this could be not only real estate, this could be gold, this could be anything like US treasuries and all those stuff. They want to have it tokenized and be the security token. and the standard for that RWA token is RW3. And also there is real estate NFT tokens like ERC6065. This kind of they want a UST to be the extension of ERC721 as some new functions, and but this is not officially formalized yet. But you guys just keep in mind ERC, that's what ERC means. Okay, and the last part of this preliminary is transaction network. So in this presentation, I will basically talk about my personal experience of research, and I always interested in this kind of network. So example of the transaction network is this. So basically, from the paper we recently published in IEEE conference on blockchain and cryptocurrency is we kind of care about airdrop hunters, which is there's airdrop means free token offer. It's like when some new protocol started for the early users, they offer you some free tokens, or you just register on the social media, they give you some free tokens. This is like promotion, right? This is like in real life, a new restaurant opened, they will give you some early promotion. It's the same stuff. And there are a group of people who are just trying to get this free tokens by meeting the requirement they require, but they will no longer be the regular user. They just want to grab the free tokens and leave. This is called airdrop hunters. And they have some patterns. They will have multiple addresses, and each address is founded by one address, and later they do something like on purpose. This is just one example of what the transaction network is doing. So here you can always have, we have already talked about what is transaction, right? So if you have a figure, if you have a graph, every node is address and every edge is one transaction. You can always have a snapshot of some blocks to draw a figure like this, a graph like this, no matter what your interest. So my personal experience and research is basically about understanding what's happening here. So it could be anything. This is an example of hunters, but we can, if you're interested in decentralized exchange, if you're interested in how people traded stablecoins or RWA tokens, you can interested in anything like hackers, scammers, airdrop hunters, like the fraud detection is one thing. You can also interested in what's a mixer. Like mixing service is something they have a group of a lot of addresses prevent you from tracing the token flow. And if you want to trace what my money eventually go, what the money eventually went, is kind of you're interesting checking the mixers. But in general, it's something like giving you a figure, how can you understand what's going on here? It's a huge field. Like it could be a lot of things going. So that's exactly what my talk today is mainly about. So like Dr. Li invited me to give this talk of my personal research. So I just have it simplified, and I won't go to details, but I will just briefly mention what's each kind of research topic is going on this field. So in general, the research is kind of like you can always develop method for on-chain understanding. So given the address, given some transactions, given the graph, can you understand what's going on here? It's basically that. And they have multiple semantic levels. We mean semantic levels by the level of data and level of abstraction level. For example, we mentioned that you can have a network, a graph of transaction. That's purely just a graph. So like this on transaction level, you see the graph like address A transfer to address B, transfer to address 3, address C, address D, something like that. And you have the DeFi protocol level. This is more interesting, like between the interaction of multiple contract and users. If you want to use some service, you will make a smart contract call, right? And that smart contract call will call also other smart contract. Like this unique, in traditional finance, you can borrow money, you can get a loan, you can pay back the loan, you can do whatever. This kind of like the stuff happened in the traditional finance field, and you can and all the people currently the Web3 community, and they always want to bring it on chain as well, called Web3 finance or decentralized finance, DeFi. Well, it's a term like everywhere, the decentralized finance, DeFi. The logic is simply just everything happened in the real world. of banking service, they wanted on-chain as well. So that's implement and that's realized by the smart contract function level interaction. So not just one transaction, it's a lot of transactions forming a shape of graph to eventually achieve something like loan money, borrow money, pay back money, swap tokens, all these, etc. This is the DeFi protocol level. And then eventually we will have the decentralized user activity levels is like you have transactions is the lowest level, you have a DeFi service is above level, and you have always curious about what's real people behind this wallet. Like one person can own a lot of wallets, right? It's like one real guy in the world can generate as many as wallet he or she wants because a wallet is just a address of string. You can always generate one, which means one person can own so many wallets. And if you're curious what's a real person behind it and how they interact with each other, it's kind of user activities level. The most common, the most like understandable example is the GameFi. Like there is on-chain gaming. People can have like play a video game, but with all the items and all the things on-chain. And you can basically see this on-chain game as kind of user activity because a lot of things are achieved by smart contract to say like if you buy a virtual item in the game, and that item was on chain and really worth some money. And if you're curious about this level interaction, if you're curious about how people really interact with each other on chain through the on chain game, are there any difference between social media Twitter or WeChat or whatever compare with on-chain gaming or on-chain social media? What's the real difference? It's kind of user activity levels. This is the highest abstract level of what may be interested in terms of the data. Okay, what are the benefits? But basically, why people want to study this is because if you can understand from the transaction level what people are doing, basically, if you understand the entity roles, that's for regulatory enforcement. So basically, like SEC of United States or MiCA of European Union, they're making new laws of the blockchains. What's illegal, what's legal, what should you do, and what is coin a security, is coin a financial stuff. All these things are in debate. And if you can have more on-chain understanding, you basically provide evidence of how, like the backing, how they make laws. That's for regulatory enforcement. And they also you have, if you understand financial functionality very well, it's good for market surveillance. So basically, for example, if you see 80% of the if you see for one blockchain, 80% of the transactions are made by bot or arbitrageurs or hunters, you don't feel like this blockchain is reliable, and you don't feel that's a good chain, right? Suppose there's a new chain, small chain, like after you do the on-chain analysis, you know that most of the wallet belongs to the same bot or something. You know it's kind of market manipulation, and you know that it's not reliable. So this transaction level analysis is good for making the market surveillance better, promoting transparency and understanding of market integrity, right? And eventually, for the social science, like people always care about social science. It's like before the emergence of social media, people care about how people interact with each other. And after social media emerged, like Facebook, Twitter, Instagram, like a lot of research is on that, saying how people really interact with them on traditional social media. And now it's kind of very new stuff like Meta. Facebook changed its name to Meta and want to do this Metaverse stuff. And if this Metaverse is like gonna be on chain somehow in the future, it advances economic system modeling by uncover the social structure changes. So scientists will be interested in checking, for the young kids in the future, if they play the on-chain game all the time, what's the way of their social structure change, like how they compare with the traditional, like the social for example, what's the difference between the interaction graph of on-chain game compared to the interaction graph of, for example, friend graph of Facebook, like who followed who, what's changed. That's why people are interested in this also in the academic. Okay, well, let's go through some of the research topic, and each one will be very simple. I won't go to any details, but mainly talking about what's people interest. So one thing people interest to start is the address classification. So you guys can see two figures, right? On the left, there's a Ethereum labeling cloud. It's basically like a accumulation collection of labels. For example, if one day you got an email saying, I will give you 10 free Bitcoin if you send tokens to this address, and someone is like very naive to actually send that. Uh, and later the guy find out like, oh, I'm scammed, and this guy will upload something like, okay, the address of the email, the address the email said I need to send token to is actually scammer. So that guy will upload a request saying, I know this address is a scammer, and that once that verified, that address will be labeled scammer. So that's people need this kind of labeling cloud, but it's very limited. Like you got thousands and millions of thousands of addresses on every chain, but the labels are very, very limited. Like even, for example, for the scammers, it's just a couple of thousand addresses are labeled, but there are like I don't know how many millions of addresses or a billion of addresses even. So the label are always limited. So people always care about can you do some AI stuff or math stuff to actually do some pseudo labels so people can know that, okay, this address is of high risk. That's one thing people are interested and normally do. And we already seeing a lot of papers doing that. It's kind of, I don't think it's very interesting, but that's quite needed by the community. And also there's one figure on the right. I feel like Doom, their service is much better, not much better, but I mean, I prefer using that because there's a lot of labels and you can use SQL kind of queries to query the database of theirs and get some labels of the Doom they collected. And sometimes it's quite useful to get some insights of what's possibly behind these addresses. That's one research topic. And we can have something like graph-based representation learning on that. So I will skip that. This is like one example of how people can do that. It's basically you have the transaction graph, you learn the representation, and you have classifiers like machine learning classifier. So I used to have a paper on that. So you can always have node level representation learning or edge level representation learning or graph level, depends on your interest. And eventually you have a result saying, I have a classifier, and that's possibly classify like 80% of the my data to be accurate on the potential labels, something blah blah blah. But I will skip that. But the idea is like you can always have much AI-based classifiers for labeling, like giving them potential label of addresses. And a different problem in this field is the blockchain transaction graph is very big. It's quite large. And you're always trying to find a way to learn that representation of graph not that expensively. So if you want to apply the like GNN, GCN, the graph convolutional networks directly on the blockchain, it's like you need a very, very huge amount of GPU memories, and that's quite expensive. And we always care about in the blockchain research community of AI and yeah, transactions on AI models on transactions, you always want to calculate everything not that expensively. So one research view is how you can save the memory, how you can learn the representation with less computation as possible, and how you deal with the dynamic growing of blockchain because the blockchain transaction graph is growing bigger and bigger, right? The old transaction will not disappear, but there's always new transaction appear. So the graph will be bigger and bigger and bigger. And I used to have a one research on that. It's something like we can skip the not important nodes and focus on the more important nodes and learn the representation based on that to save some computational cost. That's one another research question of this topic. Okay, the first topic down. Ooh, okay. I won't go too much details. Hope you guys know what I mean. The first research topic is about predicting labels of a contra of a address, and that's down. Pretty cool. And the second one is people analyze this transaction graph to see the arbitrage, to do the arbitrage study. So arbitrage means you can make money and you can use a bot to make money, and other people sometimes are not me or you. Some smart people or some people with a lot of monies are making monies, and they always need to have a lot of money first to make this kind of money because there's cost for that. Saying here is the example. So someone got 6,000 USD. I don't know if this may be too small, but I will just briefly describe that. So someone got 6,000 USD, USD, USDC or USDC, right? And that guy found that on the other chain, there's a chance of arbitrage. So this guy transferred the 6,000 USD cross chain to a different using the bridge to a different chain. So cross chain means there are two blockchain. You can transfer tokens between two blockchains as well by using the bridge. And on the other blockchain, the 6,000 USDC can be swapped to 3.5 million something banana token. So there's actually a token called banana. It's so funny. And this could be anything, could be a token. So the banana token, and that guy swapped back the banana tokens on a different blockchain to $6,028. So which means initially that guy has $6,000. And that guy noticed some chance to make money and use a bot to send a cross-chain transaction and a swap to banana token and swap back and make $28. So after this kind of all those behaviors, this guy from owning $6,000 to $6,028. So that guy noticed this chance, and there's a bot that guy deployed to do the arbitrage. That's how arbitrage means. There could be sandwich attack. This could be multiple types of arbitrage. We won't go into the details, but it's something like on chain. There's always a chance to make money, and normally there are some people who is rich and who is also known the chance very well, who write some program to have bot automatically to earn some money. So that there's one research field of this topic is like to study the arbitrage bots, to explore the price discrepancies across blockchains, and to learn to check the latency and transaction time, and to check the risk because everyone wants to do the arbitrage and sometimes fail, sometimes successful. It could be something like you start with 6,000, but you end up with 5,000 something. You can lose money if you don't do the transaction well, but people either want to study how people really do that, what's the strategy of doing arbitrage, and how in history how much money involved in the arbitrage, and how people use anti-arbitrage strategy. All this kind of sub-research field of this large topic. This could be multiple type of research. And a third research topic is we already mentioned earlier is airdrops hunting stuff. So people this kind of like arbitrage is something like if a new protocol, a new project started, they will give early users some free tokens, and some hunters will just use like they just do the farming. They just try to see what's the requirement they need to satisfy, and they just satisfy the barely minimal requirement to get a free token and just leave. No longer use the product anymore. And we used to have a paper published this year for that. For example, I'll give the example is there are some patterns. If you have a transaction graph for me, we will check what's the initial funding and common receivers. We'll check what's the sequential transfers of the time and uh, cross-chain transactions, the gap between the times of them. And we'll check the uniformity of transaction counter values, like how close of this amount of money transfer, like there will be a very similar number, and in terms of a count of volume. It's something like in this way, we can detect and found here's the example of the most, like the hunters getting the most money of hot protocol as example. And after analyzing the graph, we can see like how exactly these hunters get, like how much they earn, how much they lost, and what's the possibility of earning some money, and how exactly they end up with like some hunters losing money. So which is kind of expected because they have the bot, they have the program doing that. It's not doing by a human, and sometimes the bot is not working, or the kind of fluctuation of price make the actually the arbitrage kind of making the hunting stuff failed is possible. So we can, by analyzing the on-chain transaction, we can see how much they earn or how much they lost. It's quite interesting to do that. And you can see that maybe 70, 80 of them actually earning some money. Of course, if we check the hunters and we see that 80% of them failed, then there won't be so many people want to be the hunters. So it's kind of as we expected, like 70-80% of this hot protocol hunters, they actually get some money by doing this hunting stuff. And it's pretty interesting. Okay, we have finished the topics of transaction level. Now let's go to DeFi functional level. So as we mentioned, like DeFi function is something like in the protocols you can do swap, lend, providing liquidity, or all those stuff traditional kind of financial institutions doing, and also on-chain people, Web3 people, blockchain community wants to do that as well. Here I have example. We used to have a work saying what's the shape of these financial functionalities. Like swap is basically, if you guys see the first figure here, so all the swap look like this triangle stuff. So it's basically a factory deployed contract giving three calls to the assets contract. Why we need three assets is because we have an intermediate assets in the middle. For example, if you want to swap one Ethereum to, for example, Polygon, and will be one contract in the one asset in the middle as an intermediate, for example, could be stablecoin, right? Could be Uniswap coin. Let's say it's a stablecoin. So something like you have Ethereum, you want to swap to Polygon. It first swap your Ethereum to USDC, and then you use the USDC to swap to Polygon. Something is something intermediate needed for the kind of pool stuff. Like they have multiple pools of the token pairs, and they are doing this way. So basically, all the Uniswap or SushiSwap or Uniswap fork automated market maker, they're doing something like this. So by analyzing the shape, we actually can know what's going on, right? If this is not something like before analyzing, people can know. This is something like we extract the data, we analyze data, and we tell people like, okay, swap look like this. So it's quite interesting. It's something like you have low level data, and you can always analyze and build the construction of higher level data to understand what's going on and on the field of blockchain. And the second one, I won't go through all of them, but I want to mention the second one is like swap exact ETH for token. Like the first function is called swap. The second function is called swap exact ETH for token. And it looks like it's a bit more complicated. It has two level, this tree. Why is because if you say something like, I want 600 ETH back, and you tell me how many banana tokens I need to give you. So it initially it need to call some function to calculate what exactly token that guy need. So the first call to the factory deployed contract, and it goes to multiple contract to calculate that first. And you guys see the second level, it looks like exactly the same as the first swap. So basically it means there's a financial functionality. You have a shape of smart contract calls, and you have a complex stacked multiple levels of trees. And on the tree, you can always have a subtree of this tree. It could be other functions like swap exact ETH for tokens have the basic swap inside, but it has multiple other functionality add-on. So that's what's interesting, and we kind of curious, and we can analyze how this contract interact by saying like what exactly Uniswap is doing, what exactly 1inch is doing, right? You can basically basically distangling this. You can distangle this compositions, and you can try to understand what's basically that's called building blocks of this. It's down by the co-author of one of my paper, Stefan Kessler and Pietro Sagis, and they're kind of pretty good about this. And we have some unique data set produced that's public on my GitHub, and it's like we have data set of unique 10,000 DeFi building blocks of these trees. And if anyone wants to research on that, can download that data. And yeah, that's the DeFi functionality. And what interesting is we used to do clustering on that, and we have all these trees. And if you do graph level representation learning on that, we can know this like kind of which protocol is close to other protocol. That's pretty interesting because let's say, for example, SushiSwap was a fork of Uniswap. Fork means someone copy your contract and start their own. This is quite common in the field of blockchain. It's something like one if they're public and if they're allowed it to I don't know what license allowed you to copy, you can copy and make your own version of you like, build your own community. That's what happened by the SushiSwap and Uniswap. So SushiSwap, Uniswap start early as the first kind of decentralized change service for Ethereum on Ethereum, and SushiSwap was a group of people want to like do the fork and change something logic and build their own community. And we see that SushiSwap by analyzing this tree-shaped kind of building DeFi building blocks, we know that SushiSwap basically every node of SushiSwap, like every this small trio of functions of SushiSwap, very close to Uniswap. So during our clustering, we can first identify the potential financial functionality, and we can basically detect like which protocol is a fork of another. Somehow, it's pretty interesting. Let's say in the future you give me some transactions and you say, "Ah, this is a new protocol. I don't know what this new protocol is doing." And by using our model, you can basically see that it's potentially a fork of Uniswap, or it's potentially a fork of Ava, or it's doing something similar to Uniswap and Ava because it called the same swap and it uses the same service. But be careful, it's different in blah blah blah. It could be a scammer or whatever. But using this kind of model, you can automatically get this. It's kind of pretty interesting stuff of DeFi building blocks embeddings. Uh, it's something like this is just an example of this DeFi building blocks. Like one tree could be subtree of others, and we will just skip. Okay, let's. I have two, possibly two or three topic more, but we'll finish very close. It's already like 15 minutes. I will be quick. And the different research topic is you can do the hierarchical analysis in transactions. Let's say you have core nodes, something like highly connected wallets exchange, or you can have middle levels nodes, and you can have peripheral bottom level nodes like sparsely connected wallets. There's because on the blockchain transaction graph is so big, and a lot of nodes is just one transaction and a small amount of money. It's not that important. It's like me. I can create a wallet and send a 0.0001 Ethereum to that token and never use the token again, right? When we analyze them, those are not our interests. So we can always like check the hierarchical of this transaction graph. And one method is from the hyperbolic learning, like this Poincaré space. We can have a ball of higher level in the middle. That's just one example of the hierarchy. I mean, hierarchy could be multiple things, but one research topic, you can study the hierarchy of transaction. You don't want to give accurate label of every address, but you can roughly give them something. Ah, this is a core node, this is a peripheral node, this is a field of research. Okay, last research topic for today is a user engagement modeling. Like we mentioned, like they're actually user of that, and I used to have a paper on that, saying we study the Decentralized, which is a game. Like Decentralized, it was a is an on-chain gaming of like 2D map, and you can have like this is 2D, and every player is a small figure. There's a small guy on the map. You can actually move your figure, and you can actually walk through. Like this is just like a video game. Like every piece of land is a virtual land, and there's a like park, there's a house, there's a public like metro transportation, something like it's pretty funny. You can buy the piece of land there, and the land price, for example, one land near the metro station is more expensive than a land in the middle of nowhere. So it's pretty like real life. It's a video game of you can buy a virtual piece of land for building a house, and that's actually worth some Ethereum. It's so interesting, and we study that. So the problem is it's pretty unclear how you understand that because there is smart contract calls, there are off-chain stuff, and how you build this graph analysis, how you understand the on-chain stuff. And we have published some paper about that. So we basically study how people moving from the 3D coordinate of this game. So like every user is a small dot or small figure, and how the user walked towards this map, we collected that, and we analyze that how that's behavior corresponding to like social behavior, something like if you are on-chain player, you're a guy, and other person is a guy. If you met in the same piece of land, we say like you contact each other, right? And we check how that's different compared to the like traditional social media like Facebook. And we published this through the API. You can see like this is my course I did, and they have published all this information of Decentralized, the other side, the sandbox, all those kind of. There are multiple games, right? Each game they collect some data, and that's published through this wellanalytica.io. This one website my course I did. It's pretty cool that they share the data, and anyone interested could download data and analyze what's going on of this on-chain gaming. Oh, to be short, so our conclusion is we draw the interaction graph. So like we said, like if two users appear in the same piece of land in this gaming, we think they interact with each other. And how the result is we check the kind of complementary cumulative distribution function, which is commonly used for social graph analysis, something like Facebook friends graph. Like you follow someone, someone follow you back, we build a huge graph of who's the friends or who. Similarly, we do this by if in the decentralized the game, like two users appear in the same peaceful land, we think they kind of interact with each other, like they kind of friends of each other-ish, friends-ish of each other. And we draw this interaction graph and we have checked this CCDF distribution. And the conclusion was it has a lower average degree than traditional Web2 social media like Facebook, so it's much lower, which means the decentralized is not that much of social network stuff. It's more like people mostly just go there, buy a piece of land and want the price go up. So it's pretty driven by economic behavior or the monetary behavior. It's not like for social events. It's not as much like on Facebook, people just followed by friends. It's not that clear pattern. So our conclusion was that decentralized has lower average degree than traditional social media, but we without analyzing that, nobody knows. We hope that in future, like there will be new forming of social media on chain. It's just not happening now, but we hope it's happening in the future because it's new stuff and interesting. Okay, it's almost an hour, and thanks. That's all about the research topics, and hope you enjoy that, or at least don't feel that's boring. And I think anyone who's interested in this field there is still a lot of space for doing that, and the community is growing and there's so much data ongoing and we always want to have them modeled and have them understand. I have two more pages, sorry, for my personal stuff and this is not about research, but I'll be quick. So first one is there's a website called NFT Insider, and that website has the blogs have something like how what makes NFT valuable, and there used to be like NFT price pretty high, and now it's much down, and potentially in the future will be high again. Nobody knows. And they summarize the key factor that drive the NFT values. Could be monetary, it could function, it could be emotional, social value. It's something like you buy this expensive NFT, and that guy buy the expensive NFT. You guys both know that you're kind of rich, or you kind of it's a ticket for entering a private community, something like that. And in their website, they signed my paper, which I'm super happy. I used to have a paper called Analyzing Understanding NFT through Price Move Analysis. And when they make their conclusion, they sign my paper and saying like, okay, the data backup is from this paper. Please go check. I'm pretty happy. Like there's some real, like some website, they draw conclusion and the backup, the reference is like from my paper, and I really appreciate them. And that's why this kind of research is interesting, is because they're always ongoing, and people, if you're really convincing people of doing something, that's pretty interesting. And the last page is I have a YouTube channel talking about crypto stories, and that's in Chinese Mandarin, and I have 1,600 followers. I just started a few months ago. I hope there will be more, and I will keep making that, talking about what's Ethereum, what's Solana, how the difference, and what's the story of founders of them, etc. And if you're interested, I'm begging you to follow, basically. And that's it. Thank you. That's all about today.
Yeah, thanks for the wonderful talk. Yeah, I think that's a pretty pretty good overview, right, of this topic. Yes, let's yeah, there's a question. Yeah, you can see the question, right?
Yeah, let me go and click. I think I got a question from Anthony, and a quick question. And a lot, given how expensive GN are to train, where, when, how do you use this emerging with the crypto space? I don't know who's the more money to fund upfront capex required to train, hire, research, exact real products, commercialize it. Well, I don't know how they commercialize, but given how expensive GN are, um, basically, for the paper I read, and people are trying to use less expensive models, and people did use GN, and some of them are funded by their research group, and some of them, mostly people did is we can only analyze a very small like period of time. It's like, for example, one paper published, they analyzed the transaction graph between like 21 June to 21 August, something like. It's always like a few months or even a few days. I don't see a huge organization trying to analyze the whole block of something, for example, and they will always be like first to make the data kind of limited to a specific period of time to make the transaction graph like between like smaller than 3 million nodes, for example. And then they got some funding from the institute or anywhere they have some GPUs to train that. That's also for me as well. I used to do research on owning like 3 months. But for CapEx, I don't know. Maybe I don't know if there research, if there is a community to build a product to commercialize that. That would be an interesting idea, but I personally don't know if there is one or not.
Yeah, I think that basically yeah, he asked about if the company has, some investment or money to fund
And,
the research. Yeah.
there are some company like doing that, like the chain analysis. There are some bigger ones, like they for the on-chain monitoring. There's already some company who's not like the company was it's kind of not that small, like chain analysis. I think they hire people and they make money by providing the insights to their customers, and but they don't share that publicly. And for the study I did, or for the for people doing research in the university, people just tend to use the public data and focus on small piece of data and try to use their lab GPUs to get some research done and publish some results. But largely, I do think like it will be if we want to do large scale analysis, it must be like commercial, like did by the industry and founded by some institution. I hope that industry company can make money on that as well.
Yeah, actually, I'm just wondering, is GNN very expensive, especially in comparing with transformer?
Yeah, I mean it's quite expensive, depending on how large the graph is. But blockchain, I mean, I used to download I have a hard drive like 16 terabyte. And I have like 8 terabytes of like a Binance transaction, for example. Any like any 2 months will be a couple of gigs. And if you have like RTX 5090, it only has like 32 gigs of RAM something, and it's easily like you use up all the memory. So you need to have a cloud-based GPU for that. Do you think GN could be trained by a community? It's possible. Like we used to say, people used to say like federated learning, but I don't see that happening in this decentralized like transaction study. But if that happened, I would be super happy. Like if they're like everyone can share their part of training, and that's will be interesting. I do wonder how effective is label the scammer's address. How do you label the address without much training data? Oh, yeah, that's one I used to have a study of this. So because the labels are super rare, and one thing is you collect all the public data on GitHub and all those communities, and we don't really manually label. It's just collect as much as possible. And then there are many paper published have their result, and someone will publish their labels as well. And then all those are about you can always have a model doing the pseudo labeling, and that's something people compare. Like based on the limit data. And if they're under a pure learning, like positive and unlabeled learning, I think this is kind of the correct direction. Is positive unlabeled learning. It's because suppose you have a 3 million nodes and only 1,000 are labeled. All the rest is not negative. It's something. It's pretty dangerous to do that. So suppose you have a data set and you have 1,000 labeled as positive as scammers, and other nodes you cannot assume they're just negative. Well, largely proportion of them are negative, but it's better that we have someone manually checking like some of the addresses are for sure not scammers and providing something like if you have 10,000 node, 1,000 is labeled as negative, like 1,000 is labeled as scammers, and another 1,000 is labeled as not scammer regular users. You're for sure like 1,000 of them are not scammers, and the rest 8,000 are neutral, like kind of unknown, unlabeled. And if your learning frame is kind of PU learning space is kind of more making more sense because it doesn't treat all the unlabeled as negative. So people are using limited positive labels and limited negative labels, and you can manually label some if you're sure what's your observation. Like people have heuristic doing that. For example, for airdrop huntering, there are some patterns. People manually normally there is a GitHub page, and the issuer in the issuer tab they have something like, oh hey, I suppose this 20 address is scammers, is hunters. Here is my what I saw. They have funded by the same address, and they share very common patterns of like a bot, and other people will review like our after community-based review, and it will prove saying, okay, let's agree on this 20 address will be labeled as 100, something like this. It's very slow. As manual process is going a bit. But recently, I read some paper like people use LM and make some pseudo labels, something like you can have LM quickly analyzing all the 10,000 addresses, the behavior, and give a label at least something like this is GPT said it's possibly a scam or something. So manual labeling very expensive, and every paper they kind of do their own. Me as well, kind of look at the patterns, use heuristics eventually, and let other people in the community to peer review that. That's kind of traditional way. And then recent new ways are RM-based pseudo labeling. Also, our people publish their models. You can always apply multiple model to see whether there's a potential address of scammers and then help you a bit, automatic you a bit, and eventually it goes to manual process again. So that's what happened, I think. Yeah.
Yeah, I think a quick comment is I don't quite like, using language model to label data. There'll be something wrong, right? So it's not ground truth. So
No, it's not ground truth. It's something
yeah,
for guiding, for giving you
yeah.
pseudo labels, kind of yeah, starting that, and
On
you
the yeah, on the other hand,
manually.
I think that's maybe a good business, right? If the data is really valuable, then people try to
I
figure out some way to collect those labels. It's just something like Scale AI, right? Scale AI just acquired by Meta for lots of money. So data is
Yes, yes.
oil. Yeah,
I guess I assume like the company is already doing that. I
yeah,
think they want to lower in the labor cost and something. They want to replace people with LM all the time. It's happening,
yeah,
unfortunately. So it's kind of they don't need more people.
yeah.
It's
And
harder to find a job.
And also a comment for Antoni's question about whether we can decentralize GNNs. I think that's why we organize this decentralized AI group. Maybe if something is really valuable, then some people may do something in a decentralized way. That's maybe better than a centralized way. Sometimes people don't, maybe a single person, a small group don't have enough resources, but many people, many groups may work together to do that. That may be a business type of business model, using this way. So I think, yeah, that's why we organize this decentralized AI study group. I think, yeah,
Yeah, that's pretty cool. And I think the key point that here is like when commercialize that, which means if you make a if you let people collaborate to have a GM train together, is something like more importantly is what eventually this GM you use for. And if that can make some profits, like if this service can provide some clients, if there are some clients, I mean, if there are clients needing a large GM for their purpose, I think it's possible. Like if there is enough incentive to a group of people need this kind of service, and people can have this and decentralizedly produce it. So the whole thing is about incentive. I feel like a lot of decentralized stuff is like when there is a bull market, when there's a lot of retail money went to the community, and people can get funded of their startup easier, and then something can happen. Currently, is like Ethereum price goes up and Bitcoin price goes up, but for the other altcoins, the price is not good, which means it's not a bull market. Now it's kind of still kind of bearish, and I do hope like there's in the future there's a bull market again, like the fresh money goes to the community and a lot of new things could build. For example, this kind of decentralized GM will be very interesting. Yeah.
Yeah, actually, I just remember there's one paper, a group of people, they are, in different places, and then they collaborate together to train a 7 billion uh, parameter language model, from scratch. That's probably much larger than most GNN problems, I guess. 7B, small, large
Right,
language
right.
models, that's
That's
where
exactly
they're
what I
very,
mean.
very large. Yeah.
Yeah, currently, for large language model, a lot of money are inside the industry, and it's hot topic, not like
Yeah,
like
yeah.
currently blockchain. It's kind of so many people, so much money got involved, and it will be so it's kind of
So, so I think,
literally
if this kind of, for example, GNN based some data analysis for blockchain, if this shows value, then money will come. I see. Other questions? Actually, I have somehow a general question. How do you think those techniques will be helpful for stablecoin?
for stablecoin. I mean, for the on-chain analysis, the transaction of stablecoin is the same as transaction of other coins. And currently, most of the stablecoins, like almost every stablecoins, are ERC20. So recently I extract some data of real world assets of like for stablecoins, for example, the no matter which one you're interested, you can always crawl the data, extract the transactions and analyzing who owns the most tokens or what the flow or the tracing flows token. It's the same as the other token. So, but what's different is because RWA is going on, there'll be new standard, for example, like currently all the stablecoin ERC20. In the future, there'll be a possibly a new standard for ERC20, for stable coins and for all those Wall Street money, like they bought a lot of stable coins. In the future. Maybe there is a regulation compatible standard, for example. I will guess this will happen. So currently, if you're interested in stablecoin, you can apply the same modeling. It's the same fungible token. So it's basically USDC, Tether, DAI. They are all kind of ERC20 tokens. If you want to trace them, you can use the same token technology to trace them. If want to analyze them, like who owns the most money and what's the money flow, and who do the money laundering or not, all those topics of the blockchain transaction analysis, you can analyze the same way on stablecoins. Yeah, it's the same
Yeah.
kind of stuff. But what's interesting is in the future, if new standard coming, and if there's new way of contract building for the stablecoin specifically for stablecoin, and we can always like even we can propose a new way, right? If you can propose a new standard of saying in the future, stablecoin should have these functions, and you can have a EIP, like an improvement proposal for Ethereum. And if that's proved, you're basically the pioneer of a more formalized stable coins. That's ongoing. So currently, stablecoin is only a fungible coin. Nothing special for analyzing them. Use the same technology. But in future, either you can join in proposing a new standard for them, or other people proposing the standard, you join to review, or they are finalized, you can at least analyze them, like saying what's the difference and checking what's the difference and write a survey maybe, right? That's all.
Yeah, yeah, yeah. Stablecoin is a hot topic now. So, if your technique can be applied there, maybe there's a good chance to do something, right?
Yes, yes, it's kind of you can
Yeah,
start a startup now, but don't expect that startup to make money. It's just something like you keep it yourself alive and waiting
yeah.
for the bull market to come, and
But
hopefully you can.
stablecoin is, I think lots of people are talking about that, and yeah,
Yeah, but mostly most players are big institute. So currently it's not retail people for to join in as stablecoin, anything above stablecoin is something all the big kind of large institute to do that. It's kind of all the Wall Street guys.
okay, okay.
All
Yeah.
right, thanks.
Let's see if there are more questions. Uh, let's count three, two, one. Yeah, it seems. Yeah, yeah. Let's thank Julian again. I think for the pretty wonderful talk. Great overview. Yeah. Thank you.
Thank you for your time and
Yeah.
take care. See
Thank
you.
you. Yeah. You see.